everyone. Welcome to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and his brother Joel Chaiken. We are here to help you figure out how to approach SAT math questions. This is now in a calculator section of the test, problem 1, so you would think it shouldn't be that hard. I don't know about you, Seth, but I haven't looked at it at all. That's my policy, is to look at these as little as possible so I do them cold. Okay.
Yeah.
Here we go.
My policy is to read them when you're talking.
So you got to jump on me. So you have to give me a second to read it. Okay, good. Okay. Anyway, please, everybody else, look at it, pause, and then come back. Here we go. Obviously, a word problem, or what is traditionally called a word problem. The monthly membership fee for an online television movie studio is something. The cost of reviewing TV shows online is included in the membership fee, but there is an additional fee of $1.50 to rent a movie online. So you get some, they give you something else. It's okay, good. They give you some extra stuff. For 1 month, Jill's membership and movie rentals for $12.80. How many movies did Jill rent that month? I don't know how many people recognize this, but this is the classic y equals mx plus b
It's
problem.
not an algebra problem.
What do you mean? It's not an algebra problem. I mean, right? Okay. This is
Look. This is the way. This is the way I approach
it. So, Seth, you do it, and then
this is first of all, there are two ways to approach this. One is to use common sense that you've learned to solve word problems before they taught you algebra, and that makes it very easy. Okay. Approach 2, translate it to algebra like they teach you later in school. I prefer the more elementary way. So should we do both?
So I'll tell you what. Let's take turns, okay? Let's be brothers about this. Which one do you want to do? Why don't you do it the cool way, and the elementary way, and I'll do it the y equals mx plus.
Yes.
Okay, fine. So you want to go first?
Yes.
Go ahead. Go first.
Okay. Well, I circled the. You could do this. If you have your pencil. The membership fee, not including movies, is $9.80. The amount she paid for 1 month, including movies, is $12.80. This is for 1 month. She rented an unknown number of movies, and the problem is, how many movies did she rent? Well, how much did she pay for movies? The difference between $9.80 and $12.80 is $3. So she paid $3 for movies. Each movie is $1.50. There are $2 $1.50s in 3. The answer is 2.
Very nice. Very nice. Very efficient. Very efficient. That was really good. I'm in a y equals mx plus b mood because I've been giving advice to a bunch of people. That's the unit that's usually done around this time of year. So I'm in a y equals mx plus b mood. So I am at a disadvantage, right? Because I'm coming from it from a tainted point of view. Seth's coming from fresh point of view. From the y equals mx plus b point of view, which as Seth said is probably the more traditional way of doing it, you would write $12.80 is equal to $1.50 x. $12.80 is equal to $1.50 x plus $9.80. And then you subtract the $9.80 from both sides. You get $3 is equal to $1.50 x, and then you see x is 2. They theoretically, if you do each of these fast enough, they're about almost the same amount of time. But Seth's way is better because you don't have to bother writing all this equation stuff. You could just go directly and see that clearly the $9.80 of the $12.80 is a fixed cost. You always pay that. So the difference between $9.80 and $12.80 is the amount of money to rent the movies, and it's $1.50. Yeah. So yeah. Those are the two ways of doing it.
This kind of a question is done, you go on, you buy stuff. Oh, yeah. When you're making change, like street vendors. So we come from we're based in New York, especially Joel, where there are no street vendors for food, for souvenirs, for jewelry, for knickknacks. art, and they make change. They don't. They don't. Many of them don't use a calculator, and they do arithmetic in their heads.
Yeah. Yeah, like the good humor band, the good humor person.
Yeah.
The good humor person who has the little clingy thing,
Yeah.
the little metal thing where you do the quarter and the nickel and the dime.
Yeah.
I was fascinated by those things.
Yeah.
The belt.
The cashier's method of subtracting. You know what that is? To subtract, to find the difference between 980 and 12. What you do is you start with 980 and you add to it until you get 1280.
Right.
So I could say 980, 1080, 1180, 1280, $3. It's $3 for the movies. So I say, okay, it's $3 for the movies and $9.80 for the TV.
Right. Okay.
2 movies, $3.
Yeah, that's pretty standard stuff.
Yeah.
Okay.
However, now there the one value, the one really important reason for connecting the y equals mx plus b approach to this is so that you could learn how to translate problems into algebra, starting with easy problems, so that you are skilled and ready to learn to do it for harder problems.
Right.
And then when you get then you reach a point where, say, when you get into engineering, the problems are so hard, they're so complicated that you must translate them into algebra in order to understand them and to solve them, and nowadays to enter them into a computer.
Right. Good. Exactly.
So that's why they teach. That's why they teach from word problems that are taught that kids learn to do by arithmetic. They move them into solving word problems by translating them into algebra.
Right.
It teaches people the meaning of y equals mx plus b.
Yeah.
What do those means? Why not? Right?
That's funny.
M&M's, yummy candies. Bzz, a B, y equals mx plus b. What does all that mean? Well, here, M is a rate, dollars, the amount of dollars, dollar and a half for one movie. X is the number of movies multiplied by, number of movies, like she has 2, is multiplied by the price per movie, which is $1.50. The $1.50 is the M. The 2 is the X, and the B is the constant that's charged per month for 1 month of service, which includes free TV. The plus means you add the $3 to the 980, and the equal sign says that the total bill is the sum by adding of what MX stands for plus what B stands for.
Right. Yeah. So when you said the 150, you actually should have put a unit in there. The slope is $150 per movie. It's really important to units keep you honest in these problems.
Oh,
and
yeah.
Said $1.50. The slope, particularly the slope, should have a unit attached to it, not just a number.
Yeah.
So they just,
here they ask how many.
Yeah. So then
okay. Right.
Yeah, and know when Seth said all that, when you write this, you should get it a good habit when you do this on tests and on more tests that aren't as timed to have a let statement. Let X equal number of movies. Now, some teachers insist on a let statement, but the way I view it is a let statement isn't done for the teacher. The let statement is done for you. And the reason why you write the let statement on questions that are so obvious like this is exactly why Seth said, When you get into harder problems, you really need that let statement staring you in the face, because you're in harder problems. You're gonna forget what all the different variables are. So it's a good idea to do really, really simple problems. Well, particularly on the school side, not on the SAT side, we can do them faster. But on the school side, do really, really simple problems, a long and slow way, and very methodically.
Yeah, and another reason to learn to do that is so that you could communicate to other people what you were thinking.
Yeah, communication is critical, particularly when you're working in a job. You can do anything you want, but if you can't communicate what you're doing, you're going to be limited in your job opportunities.
Yeah. What you do is with the communication, convinces people that you solve the problem in a logically valid manner, and that your answer is therefore correct.
That's right. Yeah. And one really last point about what Seth said, to pick up on that, about how to do, when you do easy problems, do them the same way you would do a hard problem. So many people, if you ask a question like, it's $6 an apple and you buy 3 apples, how much do you spend? Well, everyone would say $18, right? You don't even have to write that down. But it's not a bad idea when you're doing these problems to actually write that down, so that you get in good practice. Dollars per apple, $6, 1 apple, 3 apples, how many dollars? And you solve it this way, even though it's, of course, the answer is 18. But practice on really, really easy problems, doing it the way you should do all ratio problems, which is put the units in and then put the numbers in and then solve the ratio. So,
well, I think when you practice for the SAT, you should do both. Do both, right. Because when you actually take the SAT, you need to get the best score. To get the best score you can, you need to spend as little time as you can to get the correct answers on the easy questions, so you could bank time for the harder questions.
Right.
And then so some practice. It makes sense to write out every detail, so you practice making your thinking conscious to yourself, so that you really know, so you know that you know what you're doing. And then other practice tests, you try to do it as fast as you can.
Right. That's right. Yeah.
And then when you do it as fast as you can, of course, you need to go back and check it against the answers. And if you made a mistake, that is very good information. It's great to make mistakes.
The best information
when you're practicing.
Yeah, absolutely. Okay, today's Throwback Thursday. Whoa, look at that! This feels like a long week though, just for me. How are you, Seth? Did this week fly by, or was it sort of
it seems like a long week.
Seems like a long week, right? Yeah. So we identified this problem. This comes from a old test maybe 20 years ago. It may be easier than it is. Every time I see a geometry problem, I always think I can't get it done. It looks hard, but then I digest it and it comes to me. So let's do this. So then this is from an old test. On Throwback Thursday, what we do is we go back about 20 years and we look at tests that are predate 2016, when the SAT changed basically changed the whole feel of the math test. So here we go. So, and Seth, okay, everyone, I have to concentrate now because I haven't looked at this yet. Okay, in the figure, CAF. The area of C. Where is CAF? CAF is equal to the area. Oh, okay.
Okay.
What is this? So in other words, we want to know. I haven't done it yet. We want to know what this is. Wait.
I don't know. Let's use color.
Area of triangle is area of rectangle. Oh, we know the area of rectangle, don't we? It's 7 times 15, which isn't that 7 times 15? So I'm doing the old fashioned.
The rectangle is CD. The rectangle is CDEF.
Oh, I can do this.
The rectangle is CDEF.
The area of the rectangle. I can do this. The Zipeboard froze. It's like,
Yeah.
I could do this. Hold on.
That's it's written this way.
Come on, Zipeboard, wake up.
Yeah.
Oh God, 7 seconds feels like it sounds like the
And
years.
the area of the triangle
Yeah.
is triangle CAF.
Area is equal to 1/2 the base.
So the triangle is this. And they say the two areas are equal. And the question is, what is AG?
I may have to get a new computer. Ooh, my computer's freaking out on me.
Yeah.
Base times. Oh, this is not good. I'm gonna have to use my hand. Base. Wow, my computer may be dead. Base times height. Base times height is 105. Right. Base times height of the triangle is it's 210. Base times height of the
wait. What's the area of a right triangle?
Well, 1/2 base times height. The base times the height
right.
is
1/2 of base times the height.
Yeah. So, but the area of the rectangle is 105. So base times height of this thing is 210. So 7.
Yeah.
7 plus x times 15 is equal to 210. And I don't know if this is a calculated test or not.
7 plus x times 15
is 210.
Equals 210. So we want to solve for x.
So why don't we try to be fast?
Oh, you could. Okay, I see right away. 21 is divisible by 3. And 210 is divisible by 5. So you can divide 15 into 210.
Exactly.
One way to do it is first divide by 5 and then divide by 3. Or else another way is to do long division.
No, divide by 3 first. You get 70. Okay. You get 70 over 5. Right?
Yeah. So I like to do it more neatly. 7x. Oh, sorry. See that? Let's get it right. Okay. Let's do it neatly. 7
let's do it right.
Plus x.
Yeah.
Quantity times 15. Right. It equals 210.
Right. 7
so
plus
here's
x
how I
times
do it.
15 equals 210. Right.
All right. I'll do it on the top. Could people see it?
No, wait. No, hold on. Now, not yet. Not yet.
Do people see my red writing?
Not yet. This thing froze again. I may have to get a new computer. This is horrible. There.
Should I do it on the bottom?
No. South. We got it. There it is. Now people can see it. Go ahead.
Okay, so write it neatly.
Yep.
Now get rid of 5s. Divide 15 by 5 and get 3.
Okay.
Divide 210. This is a little bit tough. 20 divided by 5 is 4. A remainder of 10. 10 divided by 5 is 2, right?
Right.
And then divide by 3. We get 1, and 3 into 12 is 4. So we have 7 plus x equals 14. X is therefore 7, because 7 plus 7 equals 14.
Right.
Now, having done this, I could do the arithmetic more quickly. It's instead of dividing by 5, I happen to see a 21, which is in my memory of multiplication tables is 7 times 3. So let's say divide this first by 3 and get 5. Divide this by 3 and get 70.
Right.
And then divide 70 by 5. Well, there's 70. 70
no, you wouldn't do that.
50 plus 20. This is how you do math. Is a calculated question or not?
We probably, I don't know.
Yeah.
We'll find out. We'll look later.
Yeah. So 70 equals 50 plus 20. How many 5s go into it? 10 plus 4.
Okay.
So I guess same thing. 7 plus x equals 14. X equals 7.
Okay, so then two things to review. Did everybody see how to set it up? You calculate the area of the rectangle, which is 105. You write the formula down, 1/2 base times height. Please I suggest write all the formulas down in geometry so it's staring you in the face. You know the base
Okay.
is 15. The height is 7 plus
The
x. Okay, 7 plus x. So you plug it in here. You
the
get
area.
1/2. 7 plus x times 15 is equal to 210. No, is equal to 105. You multiply both sides by 2, and then you get 105 is equal to 7 plus x times 15. That's what Seth had. So I always
Yeah.
suggest...
So here are the two area formulas.
Right.
The
Okay.
area of a rectangle is a rectangle.
Right.
Is the base is this product of the base, the length of the base and the height.
Right.
And the area of a right triangle. In fact, the right area of any triangle is the product of the base and the height divided by 2.
Right. Right. Yeah.
And here the height is the length of the height is the length of the side, because the angle is a right angle.
That's right. That's right.
Now,
That's
of course,
right.
the relationship between the area of a right triangle and the area of the rectangle that has the same right angle sides is 2. Because you could take a,
Right.
you take a right triangle and double it, flip it around, reproduce the triangle, turn it around, rotate it, and then glue it, make a copy, rotate it, and glue it back. What you get is a rectangle, and this demonstrates that the area of the rectangle, is twice the area of the triangle. So the area of the triangle is half the area of the rectangle. When the triangle is a right triangle, and the base and the heights are the same.
So then, right. So then, on the geometry side, we figured that out. On the equation side, there are so many different ways to do it. 7 plus x times 15 is 210. The one you don't want to do, but the one that everyone does, is you distribute this. 7 times 15 plus 15x is 210. This is probably not. Try to get out of that habit if you can. Try, but it's hard because everyone will do it that way. But I think half the people doing this problem are doing that way. One thing you could do.
Well, let me give some tips. Wait. Let's give people tips. Let's take half of those people who are going to do it this inefficient way. Let's steer them the efficient way to do it.
Okay, but Seth,
let's
finish.
tell them why. Here we go. Let me do
Seth,
it.
No.
You want to solve for x.
Seth, could you stop it? Let me finish.
You want to solve for x.
Seth.
So you want to pull x out.
So frustrating. Seth, can you let me finish?
No. Okay,
no,
go. You
let
finish.
me finish my thought and then you go. Because if we... It's not going to work if I talk and then you're interrupting. Just let me finish my thoughts and then you can talk, okay? Okay. Seth, okay. This is not... Most people will solve it this way by distributing it out. It's not a great way. Now, I hear what Seth was going to say, so I'm going to beat him to it, believe it or not. You really want to... When you do problems like this, you really want to isolate what I call the X thing, the term with the X in it.
No, it's the term that you want to find.
Seth, let me finish.
Yeah.
Let me finish. I don't interrupt you. Okay, let me finish. You really want to isolate this term, so you really want to get this. So really, not a bad way to do it is 7 plus x. Divide by 15 on both sides, so you get this by itself. You see?
Yeah, that's not bad.
Now that's not bad. Now here you would hit it with a 3. You would hit this with a 3, so it would be 70 divided by 5. It's not great. 70 divided by 5 is a pain. Look at this little trick. 70 is 50 plus 20. See that little trick? You break. That's what Seth did, but he did it in his head. I'm not doing it in my head. 70 plus 20. 70 is 57. 50 plus 20, right? So I could do this. 50 over 5 is 10. 20 over 5 is 4.
Yeah.
Except that doesn't sound right. Is that a 14? Yes, that is a 14. That's right. That is a 14. So you see that little trick we did here? We sort of split the 70 up. Now, okay, so that's 10 plus 4 is 14. So that, right? So this is 7 plus x is 14. So it's pretty clear that x is 7. The other thing that, Seth, what you did here is at this point, believe it or not, when you, and this is my last point that you could have the floor. At this point, did you notice what Seth said? He divided by 3. He got this fairly easy equation. 7 plus x times 5 is equal to 70. And Seth divided by 5. Be flexible. If at this point you do distribute, it's easier math. If you distribute here, you get 35 plus x is 70. And it's obvious that x is 35. But Seth, when you divided by 5 again, when you divided 70 by 5, it took you a little time. It's hard to divide 70 by 5. But it's relatively easy to multiply 5 times 7 to get 5 times 7 to get 35. So it's interesting here, right? Because if you keep dividing the way Seth did, it actually, you got to be flexible sometimes. You got to be flexible.
Yes, you're right. Oh, wow. Very clever. Except that.
Right?
Yeah,
so
you missed the 5 here.
What? Yeah. 6. Oh, yeah, you're right.
You didn't write in the 5x.
Oh, right. Yeah. You're right. I did miss the 5.
Yeah.
You're right. I did miss the 5. Yeah. I would have. Yeah. Right. Yeah. Oh, so maybe I'm wrong. Maybe my big talking is all wrong. Yeah.
No, but I see your put. That's a very That's an exact. Yeah. That's if you look out. It's a good idea to look out for coincidences like that. That's a great find, Joel.
Nobody wants to do 70 divided by 5. But if you do 70 divided by 5, get in the habit of doing God, this is horrible. That's the way the screen freezes. Get in the habit of doing this little breakup here. See this little breakup? It really, 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 really helps. Really helps. See this little cute little trick there? 70 divided by 5, 50 equals 20, and then you do each one. Play with that. I'm talking to the people there listening to this. Try that yourself when you have division problems. You'll see the speed at which you can do division problems. Okay, I'm going to erase everything I did. Okay, Seth, now it's your turn.
What are we doing?
It's your turn now. It's your turn.
I did my thing.
No, you didn't, because you said you were going to say, let's go over why it's inefficient to do the original distribution like what most people would do. And you said, I'm going to say why. And
Right. No, so, leave the blue. Leave it as it is. What I was going to say is, okay, here we are. No, leave the blue. Please. Leave it there. Okay.
Yeah.
You suppose you're right. Here's the equation. Now, your goal is to find or solve for x.
Yeah.
That's the goal. So you need to pull the x out and get it by itself. If you distribute the 15, what you have is a term with 15x. And so that later you'll have to go back and divide out the 15. It's better to keep the x by itself. So here, one choice, you get this choice gives you an x by 15 times 15. The division method gives you 7 plus x equals 14. So again, so this gives 7 times 15 plus 15x equals 210. X times 15 equals 210 minus 7 times 15. Whenever you figure this out, then you have to solve for x. But if you do this, divide out the 15, you get x by itself. which is what you want to find. You want to find the x by itself, not the x times 15.
That's a really good theoretical explanation, and it turns out it has a lot of practical applications.
Yeah,
That if you multiply the x times 15, you're going backwards in isolating
yeah,
the x. Yeah, yeah.
yeah, yeah, yeah.
That's the best way to say it. That's the really best way to say it.
Yeah, 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 yeah. Yeah, you have to dive into the pull the X out.
Yeah, yeah. That's good. That's why it's helpful to think like Seth theoretically. See if I'm at like slightly higher level than most of us. So
Yeah, yeah. So your goal is to solve the problem, find X.
right, right.
Just which and you are simplifying the equation. The purpose of simplifying the equation is to reach the goal. Simplifying the equation is not the goal in itself.
Right.
Yeah, and yeah, yeah.
Okay. Now let's see. This may have been a
Okay.
moot point because this may have been a calculated question. So
Yeah.
let's see. Was this a calculated question? This was. Let's see. Was this a calculated question? Drum roll, please. They don't say.
Oh,
Use of calculator is permitted. Oh my
yeah.
god. So
Okay.
all of that is moot. You could have just
Yeah,
used a calculator.
yeah.
You could have just used a calculator.
So
Oops.
with that
Oops.
generation of calculator, did the calculator have a linear equation solver?
That's no, but you would what? Yeah, but the amount of time you would type that in would probably be faster. Just
That's
to
right.
multiply.
Yeah.
Yeah. Oh, so guess
Yeah.
what? You could have used a calculator. So then you
Yeah.
could have used the way that we are arguing is not preferred and not as efficient. But because you can blast it with a tool, then you could be slightly
Yeah.
less efficient in the method.
Yeah.
But the calculated method of the technology supports you a little bit and gives you.
Again, I think if you had a calculator, it is still faster. It is still faster. When you get to this equation, to divide the 15 out using the calculator,
Right. Yeah, I'm going to do it now myself.
than it is to
Yeah.
multiply
Right.
the 15 through.
Now I'm going to do it right now.
Even with the calculator.
210 divided by 15 is 14. Done. Exactly.
Yeah.
What you have to do here is divide. Exactly. Just divide the 210 by 15 to get 14, and then you see that x is 7.
Yeah.
So the calculator would help. In fact, it's probably advised to use the calculator if you can, if you have it. Yeah. Because it saves brain power. So we did it both ways. We did it both calculator and no calculator.
Yeah.
Okay.
And notice also that you really needed to ignore the scale of the figure. That the figure was drawn purposely to be misleading.
Right. Yeah. Well, anyway, in geometry, you do what's down on the paper. You don't make any assumptions.
Yeah.
You just do exactly what's told. And in geometry problems, generally, it's a good idea to write the formulas down because try not to put those in your. Try not to do geometry problems with formulas in your head. Write the formulas down. It's worth the investment.
Actually, come to think of it, well, here's come to the thing. It goes like this. Here's a geometry way. Here it is. Yeah, let me draw this.
Right, let's give you some space. Hold on.
Give me space.
Let's give you some serious space, and let's not.
Serious space. Okay. All right. Here's the rectangle. Right.
Yep.
And here is the left-hand side. And you know that this is 7. But the length distance from here to here is 7. Right? And so the question is, you want to find a triangle. Think of a triangle determined by a moving point that sits up here. Many triangles. And the question says the area of the, and of course the bottom is included also, the area of the triangle is equal to the area of the rectangle. Well, if you could then realize that if it was very tall, the area of the triangle is bigger than the area of the rectangle. If it were up here, if the triangle were this one, the area of the triangle would be only half of the area of the rectangle. But in between, when they're equal, we have symmetry. We have symmetry. When they're equal in area, then notice this region is equal in area to this region.
Right.
We have perfect symmetry, which makes, and then this symmetry is manifest by these two segments being equal, and therefore this segment from here to here equals this segment. And so the answer is when that's 7.
So, Seth, that brings up a good point. I'm not sure how many people would do it that way, but guess what? We blew this problem big time. For the people who are the smartest in the world, they are laughing at us because we blew the clever solution. And what you did is you did a geometric approach to the clever solution. Watch this. I hope there aren't people watching this who are looking at us and saying, what fools are we? Watch how you could do this problem if you're brilliant. The two areas are the same. 1/2 base times height is equal to base times height, right? Base times height of the triangle, base times height. These are the triangles, right? But we're doing this really fast.
Wait. Hold on. I hate. Wait. The base is the same, but the heights are different.
Seth, let me finish. You have to know when you're writing this that this is the triangle and this is the rectangle, right?
No, yeah.
But
what you do is
no.
Okay,
Seth,
you put height triangle and height rectangle. That's how you show it.
Stop. You don't have time for that. If you're that smart, look, Seth, let me finish.
Okay.
If you're this smart to do it this way, then you don't have time. You're so smart you don't have to write that down. You know that this is the triangle. You know this is the rectangle. The bases are the same.
Yeah.
The bases are the same. So 1/2 height of triangle equals 1/2 height of rectangle. Now you have to make it. Now you do have to make a distinction. The height of the rectangle is 7. Is 7 here, right? If the height of the rectangle froze, unfortunately, the height of the rectangle is 7, which makes the height of the triangle 14. If the height of the triangle is 14 and already is 7, then you know the height. Then you know that x is equal to 7. Unbelievable!
Yes,
if you do it this way, you don't even use the 105. You don't even do any of this stupid stuff. You get the answer like this if you're really smart.
Okay, no, they're really smart. Yeah. But we can say, if you're really smart and you're writing this stuff, the way to be really smart, if you're going to say 1/2 base times height of the triangle, you use a different letter.
Yes.
The first time you do it, you use a different letter.
Right.
You never write the same letter for two things that are different.
That's right. And I got myself in trouble when I did that. Notice I changed my tune. Do you notice when I crossed off the bases, I changed my tune and I made a distinction there because you really need to. And then you ask, this is 7. So 1/2 height of triangle
Yeah.
is 7. Height of triangle is 14. You already know
Yeah.
that the 7, and then you get the 7 instantly. Who cares less about the 105? We went backwards in this problem. Oh my God.
Yeah.
Wow, look
Exactly.
at that. But I didn't notice it
Yeah.
until Seth mentioned the geometric solution.
That's right. Yeah.
I bet there are a bunch of people, the really smart ones, who would do it this way.
Oh yeah.
Yeah. And this is and what's the tip off here? The tip off here is that the bases are the same. See, that's the tip off.
That's right. Bases are the same.
If the bases are the same, there are those geometry problems where you compare what is this. Some of you may have seen geometry problems where they tell you to compare the ratio of two things. I've always hated those problems. Compare the ratio of this to this, and then you realize, the bases are the same, or the heights are the same, and then you don't actually have to calculate the actual areas. You just have to calculate the ratio of the areas.
Yeah. Well, let me talk it through. Using hindsight, common sense. Hindsight, common sense. The rectangles and triangles. Compare rectangles and triangles with the same base and the same height. The triangle has half the area of the rectangle, right?
Right.
So to make a triangle and a rectangle with a common base but equal height, you need to make. No, sorry. If you want to make a triangle and a rectangle with a common base where the triangle has the same height as the rectangle, you need to make the triangle to be twice as high as the rectangle.
Right.
And then you see that in the original problem, the height of the rectangle was 7. Twice that is 14. And then you have to just make sure that your answer is not 14, but rather is how much you add to 7 to get 14. Notice they did not give 14 as a distractor.
They didn't give us 14. That's insane. Why didn't they do that? That's a gift. That's a gift.
That's a gift. Yeah.
That's a gift. My God, that's a gift. A lot of people would say 14 because you would forget to divide. Yeah.
That's right.
Yeah, a lot of people would forget that. Wow. Okay.
Yeah.
So we are.
So I think what lesson is that this kind of SAT type question, different kids who find different things cool. Some kids like art. They like sketching and drawing. That they think in terms of changing of shapes and how shapes move. And then other kids like to think of quantities and numbers.
Right. Yeah.
Right.
Yeah.
And other kids like to think in terms of algebra.
Yeah.
It's cool multiplying and adding with numbers and letters.
Right. Yeah.
Right.
Yeah. Okay. Well, we are totally killed both of these questions, particularly this one. This is interesting, right? In that we both did it not the coolest way possible. Sort of embarrassing, but that's the way it goes when you really do things. Sometimes, yeah. In the end, it doesn't mean that much time difference, but this is really a great way to do it. Okay, everyone. So that completes our Throwback Thursday for this week. Okay, everyone, have a great day. Like us, dislike us, give us comments, and send us your SAT math questions at SATmathquestionoftheday.com. At gmail.com. It's SAT math question of the gmail.com. My brain is fried. Have a great day, everyone. Bye.
Okay, bye.
Bye.